Appendix 7. Edison's Tasimeter. From Edison, His Life and Inventions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Edison, His Life and Inventions, by Frank Lewis Dyer and Thomas Comerford Martin. Appendix 7. Edison's Tasimeter. This interesting and remarkable device is one of Edison's many inventions not generally known to the public at large, chiefly because the range of its application has been limited to the higher branches of science. He never applied for a patent on the instrument, but dedicated it to the public. The device was primarily intended for use in detecting and measuring infinitesimal degrees of temperature, however remote, and its conception followed Edison's researches on the carbon telephone transmitter. Its principle depends on the variable resistance of carbon in accordance with the degree of pressure to which it is subjected. By means of this instrument, pressures that are otherwise inappreciable and undiscoverable may be observed and indicated. The detection of small variations of temperatures is brought about through the changes which heat or cold will produce in a sensitive material placed in contact with a carbon button, which is put in circuit with a battery and a delicate galvanometer. In this sketch, Figure 1, there is illustrated, partly in section, the form of tasimeter which Edison took with him to Rawlins, Wyoming, in July 1878, on the expedition to observe the total eclipse of the sun. The substance on whose expansion the working of the instrument depends is a strip of some material extremely sensitive to heat, such as vulcanite, shown at A, and firmly clamped at B. Its lower end fits into a slot in a metal plate, C, which in turn rests upon a carbon button. This latter and the metal plate are connected in an electric circuit, which includes a battery and a sensitive galvanometer. A vulcanite or other strip is easily affected by differences of temperature, expanding and contracting by reason of the minutest changes. Thus, an infinitesimal variation in its length through expansion or contraction changes the pressure on the carbon and affects the resistance of the circuit to a corresponding degree, thereby causing a deflection of the galvanometer, a movement of the needle in one direction denoting expansion and in the other contraction. The strip, A, is first put under a slight pressure, deflecting the needle a few degrees from zero. Any subsequent expansion or contraction of the strip may readily be noted by further movements of the needle. In practice, and for measurements of a very delicate nature, the tasimeter is inserted in one arm of a wheatstone bridge, as shown at A in the diagram, Figure 2. The galvanometer is shown at B in the bridge wire, and at C, D, and E there are shown the resistances in other arms of the bridge, which are adjusted to equal the resistance of the tasimeter circuit. The battery is shown at F. This arrangement tends to obviate any misleading deflections that might arise through changes in the battery. The dial on the front of the instrument is intended to indicate the exact amount of physical expansion or contraction of the strip. This is ascertained by means of a micrometer screw, S, which moves a needle, T, in front of the dial. This screw engages with a second and similar screw, which is so arranged as to move the strip of vulcanite up or down. After a galvanometer deflection has been obtained through the expansion or contraction of the strip by reason of a change of temperature, a similar deflection is obtained mechanically by turning the screw S one way or the other. This causes the vulcanite strip to press more or less upon the carbon button, and thus produces the desired change in the resistance of the circuit. When the galvanometer shows the desired deflection, the needle, T, will indicate upon the dial, in decimal fractions of an inch, the exact distance through which the strip has been moved. With such an instrument as the above, Edison demonstrated the existence of heat in the corona at the above-mentioned total eclipse of the sun, but exact determinations could not be made at that time, because the tasimeter adjustment was too delicate, and at the best the galvanometer deflections were so marked that they could not be kept within the limits of the scale. The sensitiveness of the instrument may be easily comprehended when it is stated that the heat of the hand 30 feet away from the cone-like funnel of the tasimeter will so affect the galvanometer as to cause the spot of light to leave the scale. This instrument can also be used to indicate minute changes of moisture in the air by substituting a strip of gelatin in place of the vulcanite. When so arranged, a moistened piece of paper held several feet away will cause a minute expansion of the gelatin strip, which affects the pressure on the carbon and causes a variation in the circuit sufficient to throw the spot of light from the galvanometer mirror off the scale. The Tasimeter has been used to demonstrate heat from remote stars, suns, such as Arcturus. End of Appendix 7.